Hey, Algebra 1. This is Mrs. Coons, and I was really excited this afternoon to see some of y'all come in after school to ask some questions on your homework, and their questions were excellent. And so I thought what I would do is give you a video tonight for some extra practice on how to solve for x when x is in the exponent. This is new. I mean, y'all have to get used to it. We have x everywhere underneath the radical sign in the denominator, numerator, but now we have it upstairs in the exponent. And what you have to remember is this: when x is in the exponent, you must have like bases on both sides. And when we say like bases, we're talking about these numbers right here. I either need to have an 8 on both sides of the equation, or I need to have a 2 in the base on both sides of the equation. So I'm going to have to find some exponent that will let me turn an 8 into a 2 or a 2 into an 8. Usually it's better to go with the smallest number. So I'm going to keep this 2 to the 6. And what I want to do is, with that, how can I turn the other side, 8, into 2? So I start thinking over here, well, what is equal to 8 if I multiply by 2's? Well, 2 times 2 is 4. And then if I multiply it by, again, a factor of 2, I come up with 8. And so this is what I want right here. I'm going to take 2 and multiply it 3 times, and that's going to be equal to 8. Now notice what I'm doing. Inside the parentheses is my value of 8, but I still have that x in the exponent, so I must keep that. But here's the good news. Your power of a power, you're going to multiply exponents when you have a parenthesis, so it's 2 to the 3x is equal to 2 to the 6th. This is the exact same question that we had at the beginning. We just have rewritten it in like bases. And the cool thing is, once you get like bases, you get to go to town and you get to drop those like bases. And it really becomes a whole new problem. I'm just solving for the exponents. I already know what the base would be. So we will end up just taking 3x is equal to 6. And then we're back to our terrific algebra. You can multiply by the reciprocal, but for these types, I really like to divide instead. So 3 divided by 3 is 1. So that gives me 1x, which is what I want. And 6 divided by 3 is 2. So that is my missing exponent. If I take 8 and I raise it to the second power, will that be equal to 2 to the 6th? Well, 8 squared is 64. I do not have my calculator. I'm not going to cheat, but I do know that 2 to the 5th is 32. So I'm going to take 32 over here, and I'm going to multiply it by 2, and that would make 2 to the 6th. Well, 32 times 2 more gives me the grand total of 64. So is that a true statement? Yes, it is. So you have checked your exponent. Let's try another one and see what happens. What if we had something like 9y, or 9 raised to the y power, is equal to 3 raised to the 3y power? You start to look like trees. And make that 3y plus 1. And again, I need like bases. I either need to have 9's on one side or 3's on both sides. And again, what's smaller, 9 or 3? 3 is the smallest one, and that's the one that I'm going to work with. So I'm going to keep my 3 raised to the 3y plus 1. And what can I rewrite 9 as in base 3? Well, I think that 9 is 3 squared. And I still have my y exponent up there, as strange looking as it looks. But if I multiply that, power of a power property tells me I can multiply. So this is 3 raised to the 2y power, and it is equal to 3 on the other side raised to the 3y plus 1. Wow, we've got variables on both sides of the equation. But I do have like bases. Well, that's pretty cool. So I'm going to go ahead and cancel those out. And now we have that cool power problem. And we're just going to take the 2y now. And 2y is equal to 3y plus 1. Now it looks like your algebra that we've been working on before winter break. And I want my y's on the same side of the equation. So I'm going to go ahead and subtract 2y from both sides. And the only reason why I did that is because I do not want a negative y just because I'm lazy. So 2y minus 2y gives you 0. And 3y minus 2y gives me 1y. So I have 0 is equal to y plus 1. Well, I'm going to have to start over here because I've run out of room. So 0 is equal to y plus 1. We're going to subtract 1 from both sides. And now we're equal to negative 1 and y. And if you don't trust yourself, you can always go back and check these. That's what makes these fun. Does 9 raised to the negative 1 power equal 3 raised to the 3 times negative 1 plus 1 power? Well, 9 to the negative 1 gives me a value of 1 over 9. And then let's take a look at this side. This is 3 times negative 1, so that's negative 3 plus 1 gives me negative 2. Oh, great. It's late tonight, and I'm glad that this one's working out. We have 3 raised to the negative 2 power. Negative tells me we have a reciprocal going. So that's really 1 over 3, squared. And that gives me 1/9 is equal to 1 over 9. And if I had a bigger sheet of paper, it would look better. How do you feel about that one? Let's take a look at a fraction one. And we're looking at 1/3. And let's put that inside the parentheses, okay? And let's raise that to the m minus 2. We haven't had any minuses up there tonight. This will be a good one. And what's going to happen, it's going to get easier for you because you're going to start to see multiples that you can take to turn these numbers into one or the other. I cannot turn a 27 into 3 as easily as I can turn a 3 into a 27. So think about it. Does 3 times 3 times 3 equal 27? And it does. So I'm going to turn 27 into 3. Well, that becomes base 3 then, raised to the 3rd power. And you go, great, Ms. Coons, but look at the other side. This other side, you have 1/3. I do. But how about taking that as a base 3 and raising it to a negative 1 power? Because that is its reciprocal power. So that's 3 to the negative 1 now, raised to the m minus 2. Now, I'm going to do something very special with this because it is a power being raised to a power. So I'm going to take that outer power and put it in brackets. And basically, I'm just going to have to distribute that negative 1. So we're going to end up taking negative 1 times m and negative 1 times negative 2. So it is going to look like 3 raised to the negative m power, and negative 1 times negative 2 gives me a positive 2. And that is now equal to 3 raised to the 3. And I know you're going, ew, yuck, there's a negative m. Well, don't worry about that. What I'm happy with is this. I have like bases. Yay, I'm getting closer and closer to be able to have my hot cup of hot chocolate. And those are gone. And that leaves me with negative m plus 2 is equal to 3. And let's take a look at this. I have a negative 2. I'm going to take care of on both sides. If you're hearing a strange noise in the back, it's my cat playing with something on the desk, and I hope it's something that he doesn't break. So these are canceled. And 3 minus 2 is 1. If negative m is equal to 1, then a positive m is going to be equal to a negative 1. And again, if I put that into the equation and check it out, let's do a check. 1/3 raised to the negative 1 minus 2 power. Let's see what that's equal to. That is equal to 1/3 raised to the negative 3 power. And again, I'm going to put that inside parentheses. If that is a negative, that means I have a reciprocal property. So I'm going to take care of the negative. That becomes really 3/1 then, raised to the 3rd power. So that also gives me 27. So I have this side equal to 27 and the other side equal to 27. Are you feeling a little better about that? I have one more because this was a question that came in twice. You have 7 raised to the 3rd power, and then we're going to take that and raise it to the x. And we're going to throw this in for spice. We've got 49 in the denominator. And all of that, this monstrosity over here, is going to be equal to the grand total of 1. If you ever have a fraction, I want you to think of this. Always get rid of the fraction first. Because that usually makes the problem easier if you can. This fraction here has nothing to do with that x up here or the 3rd power. So let's do this. Let's take 7 raised to the 3. It's still raised to the x. It's divided by 49 is equal to 1, but we're going to multiply both sides of the equation by 49. Are y'all following me okay on that? My handwriting tonight's really rotten. Now the 49s will cancel, and that leaves us with a grand total of just 7 raised to the 3rd power raised to the x is now equal to 49. This is now starting to look like the problems we have just been working on. And so can I write 7, base 7, and express that as a 49? Or can I take a 49 and raise it or lower it to a base 7? It's going to be easier for me again to go to the smaller one. So here we go. This becomes 7. And I'm going to go ahead and multiply this 3 times x. We can save ourselves some steps there. And how can I express 49 in base 7? Well, 49 in base 7 is 7 squared. And wow, this looks so much nicer right there. Let's get rid of those 7s. And now we're ready for our next piece of work. And we have 3x is equal to 2. It's not a very good equal sign. I'm going to divide both sides by 3. And so x is going to be equal to the 2/3 power. Okay, guys. Again, this is how you get rid of x when x is in the exponent. And I hope this helped. And I'll see you guys tomorrow or on Thursday. Take care.